Hello YouTube, this is Matty Dakota, and today I'm bringing you the first in what I'm hoping to be a three-part tutorial series on Git, where the first part will be a theoretical discussion, the second part will be a practical example, and the third part will be like advanced concepts and like distributed setup and something like that. So let's get into it. So basically what we're covering in this tutorial is that this is a beginner's tutorial, so it doesn't matter if you've got a little bit of Git knowledge or no Git knowledge at all, or a lot of Git knowledge. This tutorial should cover what you came here for. Um, we're going to talk about, as this is a theoretical discussion, we're going to be talking about how Git works under the hood, not so much how to type in command lines and stuff like that. We're going to be assuming that you're using a centralized workflow. So a centralized workflow is where basically you have a client server setup. Basically, if you're using GitHub or GitLab or Bitbucket or anything like that, you're pretty much using a client server setup. So yeah, if you don't know what that means, that's fine. We're going to be talking about what are commits, what are branches, how they work, and if we get time in this video, we'll talk about branch management and like merging and rebasing and that kind of thing. And if I end up using a visualization tool during the example, which will probably be more relevant in part 2, when I do the practical example, that'll be Git extensions, which is free, and you can get that by just googling it. What we aren't doing is I'm not going to sit here and just reel off a bunch of Git commands. If Git commands do come up, I will sort of explain what they're doing, and how they work, sort of briefly, but Git has really good documentation, and if you need any further examples on how that works, I do expect that you go and have a look at that. So basically, before we get started, I just want to kind of go over this basic terminology, where if you hear, because you'll hear me say this a lot, if you hear me say like a fetch or a pull, it basically just means that you're updating your repository from the server. It basically means that the server's got commits on it, got data on it that you don't have yet on your local machine, and you need to fetch that. You need to basically just download the work and update your repository on your machine. And a push is the opposite. It's basically taking work done that you've committed on your local machine, and you need to upload that to the server. So that's basically what that is. And I just want a quick note on cloning. Cloning isn't quite the same as pushing, as pulling or fetching. Clone is basically like initializing your repository. It's still downloading the work, but you'll pretty much only use it once. We're not going to get into cloning. It's not really in the scope of this tutorial. So yeah, let's get straight into commits. So what is a commit? So basically, a commit is a change in your work over time. Git takes the work that you've done previously and the current version of your work, and it compares the two line by line to create some kind of delta, some kind of change in time for your work. So in our first example up here, we can see that this text has changed from this text, even though it's only just been capitalized and there's no real change. Git will just remember this entire line. It'll say that because a single change or multiple changes have happened in this line, we're now going to remember this entire line. We've noticed that this has changed. We can see here that this new line has been inserted, and because this line has been inserted and it doesn't really have any previous version in this file, that these lines of text will now link to the lines of text below it. And this will basically say, now that this has been linked to down here, it'll basically say, okay, these lines are the same, so we will ignore it for this commit. And down here we'll see that this has been appended here to this line, even though the rest of the line hasn't changed. But because this line has changed at all, we're just going to remember the entire line has changed. So this line down the bottom and this line up the top will basically be treated the same in Git. And that's the takeaway here, is that commits are line by line changes, and that the way that Git determines what's old and what's new is basically it's set up in a tree graph where each commit is a node, and that its parent is basically what it's compared to. So the parent is the older version of the work, and then the child will basically be the delta of that work. Each commit has a identifier hash code, which is just used to identify that particular commit, and you can use that for like checking out a particular revision of your work or anything like that, where basically you just need to identify which, or you need to tell Git exactly which commit that you're talking about. So basically, this part is when we started to get into a little bit more of the nitty-gritty stuff, and it will help build your foundation of how Git works. So Git basically has three types of branches that it uses to organize itself, which are remote branches, tracking branches, and non-tracking branches, and we'll get into these now. If you're using Git in a command line, you can use git branch -a to list all your branches. The -a is basically just an all flag, which will also list your remote branches. Without the -a, you won't get the remote branches, only the tracking and non-tracking branches. Okay, so let's talk about what a remote repository is and what a remote branch is and what the difference is really. So a remote repository is a copy of the same repository but in a different location. So in this case, your remote repository would be GitHub, if we were to assume that you were using GitHub. So that's all it really is. It's just a copy or the same repository but located on a different machine. So Git keeps a cached copy of the remote repository on your machine in a remote branch, and that remote branch has a link to that remote repository. So if we flip over to the next slide here and look at this image, we can see that we have a remote branch called Origin, and that is linked directly to this branch here, this remote repository here at this address. You can see that it's got one for fetch and one for push, so that if you were to do a fetch on your branch named Origin, it would go to this address and it would download the repository from this address, and likely for the push, when you've done some work and you push that new work to the server, and you would push that to the remote branch named Origin. Origin is basically the default branch for Git, but it doesn't have to be Origin. It could be whatever you want to call it. And Git will push that to this address here. Obviously, this is an SSL address. If you were to be using HTTPS, you would have a HTTPS URL here instead. So, tracking branches. Tracking branches are branches where you'll be doing all of your work pretty much, and that they track a remote branch. And they do this so that they can do the comparisons required to work out where the state of your repository is in your local machine or on the computer that you're on, compared to the state of the repository on the server, on the remote server. So that here we can see that they come in 4 different states. So basically we've got 2 branches. The blue branch here is your local branch, your tracking branch, and the red branch here is the remote branch, so you can see it's got remote in front of it. That would just be the remote name, so usually it probably would just say Origin. And that is the branch called my branch on the server. So here it's a head. You can see that the local machine has 4 commits that the server does not. So this would basically mean that you would then need to push these 4 commits to the server. When you're behind, it's the opposite. So there's data on the server. There's 2 commits here that are on the server that are not on your local machine. So you would have to merge this up into this branch, which we'll talk about later. So yeah, basically what that would basically do is it would be updating the data on your local machine to be the same as the server. Here we're up to date because both branches are on the same commit, so the remote server and your local machine are on the same commit, and therefore they are in sync. And here we can see that they're out of sync, and this is because the remote branch here has 1 commit that's parented to this commit, and the data on your local machine has kind of forked off to create a completely different branch, and therefore these branches are out of sync. What you would have to do in a real world scenario is you would then have to rebase this or merge it into the commit that's on here, because Git will not allow you to push out of sync branches onto the server because they're just not compatible. So normally you'd have a few options here. You could create a new branch, or you would have to rebase this, and we'll talk about that later. To find out what status you are in, you can type git status into the command line, and that will basically tell you if you're in any of these states. If you're in a non-tracking branch, which we'll talk about soon, none of these particularly apply, and I'm pretty sure Git states you're in a non-tracking branch. So that's basically how that works. When you check out, one quick note to append here is that when you originally check out a branch on a remote server, what happens in the background is that you're not actually checking out a branch on the remote server. What happens is Git will automatically create a tracking branch and track against that branch. As I wanted to sort of state earlier, is that you cannot really modify a remote branch because it's a cached copy. You're only sort of working in this tracking branch. And here we come to non-tracking branches, and this is pretty short and sweet. Non-tracking branches are pretty much exactly the same as tracking branches, except that they don't really track. They're pretty much just branches that are on your machine but do not exist on the server. And if you want them to exist on the server, then you would have to update these to be tracking branches, which Git generally does automatically if you push a branch to the server. So yeah, nothing really to say about non-tracking branches except that they exist. So I think I'll leave this tutorial here and put the merging and rebasing stuff into a second video, as this video is starting to get quite long now and I never really expected it to draw out this long. So yeah, I hope you enjoyed this tutorial, I hope you're learning something from it, and I'll hope to see you in the next tutorial.